Hello kids, let's look at exponents and indices. This is one topic where I have seen most of the kids basically have difficulty understanding what is going on with these formulas, and when they're doing problems, right, I see a lot of difficulty in approaching them. So let's understand each of them to see that what to be used when. Okay, so let's go one by one. You may have already seen all these formulas, and if you try to mug up these formulas, it's not going to work out. So let's understand one by one. So the first one, if you look at it, let's take a to the power m into a to the power n is nothing but a to the power m plus n. This is known as the base. A is known as the base over here, and your m and n are known as exponents, right? This, everybody of you know this. Now, what is the practical significance of this particular formula? How to use it in real world? Okay, so for example, if I take 2 to the power 3 into 2 to the power 2, I know very well what I can do is that I can write this as 2 into 2 into 2, this one. Similarly, the next one, it is 2 to the power 2, 2 into 2. So I know that 8 into 4 gives me 32. This is very simple, right? So what happens now? When are you going to use this particular formula to get? So if, for example, I have something like this, 2 to the power 302 into 2 to the power, say, 312. Are you going to write it 302 times, and are you going to write it 312 times? No. So what I'm going to do is that this is the formula comes to your rescue. So if you look at it, your answer is simply 302 plus 312. So this is where it helps to understand the formula and the practical usage, how we use it in the actual real world. So this is nothing but 612. Okay, makes sense? I hope you understand how to use that particular formula. Similarly, when we go to the next one, a to the power m divided by a to the power n, which is nothing but a to the power n minus n. The bases are same. Whenever the bases are same, you need to basically just subtract the indices on top of it. So let's take an example again. So 2 to the power 3 divided by 2 to the power 2. So I can write this one as 2 to the power 3 divided by 2 to the power 2, which is nothing but it is 2 times 2 times 2 times 2 in the numerator and 2 times 2 in the denominator. If you see, these two cancel out and you get 2. But if you use the same formula, what has been given to you, it is 2 to the power 3 minus 2, which is nothing but 2 to the power 1, which is equal to 2. Make sense? So similarly, this can be used easily when you have very big exponents in a particular problem. Suppose you have something called 3 to the power 333 divided by 3 to the power, say, 233. So you're not going to write them in or you're not going to repeat 333 times. So what you do simply is that you use the formula to find the answer. So you just subtract the exponents and you get 3 to the power 100. That's your answer. Make sense? Clear till now? Okay. Let's move on to the next one. What does the next one say? Next one says anything to the power m to the whole to the power n, right, gives you a to the power, you basically multiply the exponents like that. Okay, so now let's look at an example. 2 to the power 3 whole to the power 2 is what? I can expand this one inside the bracket, which is 3 times, and outside I have another 2 times, right? So what do I need to do? I need to expand this entire thing twice. So I'll write it twice. This into 2 into 2 into 2. So how many times do you get? You get it as 1, 2, 3, 4, 5, 6. You get 2 to the power 6. So instead of doing this, what you can do is that simply can you just multiply these two exponents? What do you get? 2 to the power 3 into 2, which is nothing but 2 to the power 6. Aren't these two equal? Make sense? Okay. Let's move on to the third one. Sorry, fourth one. What does the fourth one say? Fourth one says that if you have any base, for example, a to the negative exponent, if you have a negative exponent on the top, this is where most of the kids basically get confused. So what do you need to do is that you need to always put it as a reciprocal for the same power, and it turns out to be positive. Remember this one. I have seen many kids making mistakes over here and getting confused. For example, if I have something like this, kids get confused over here. They basically cannot differentiate between the base, this is the base, and this is the exponent. So what we are trying to do is that we are only going to change the sign of the exponent by reversing. So your base doesn't change in this particular case. Your base is the same, which is -2, and this becomes 2 because this one changes to positive when you put it in reciprocal. This base will never change. Remember that one. Okay? So this is where most of the kids have been doing things wrong. So we need to understand how to use it judiciously over this formula. Now the next one, a to the power 0, anything to the power 0 is 1. That's basically given. Now somebody may ask you then, can you prove this, that anything to the power is 0? So what I'm going to do is that I'll just take a to the power 0. Can I write this one like this? A to the power m minus n. I'll use this particular logic. I'm going to use that one in the reverse way. If you look at it, I'm just putting these two. M minus m is 0. We know that m minus m is 0. So I put it that way. Now, based on this particular formula, how can I write this? Can I write this one as a to the power m divided by a to the power m? Which is nothing. It is a to the power n divided by a to the power m. If you see, they both cancel out and gives you 1. That's the reason we say that anything to the power 0 is 1. If somebody asks you to prove this particular formula, you can prove it this way. Fair? Okay, let's move on. Next one. What's the next one we have on the list? We have this one. Now if you look at clearly, here you have, don't get confused, this one with the first formula. Okay, so what are they saying over here? Let me put the formula first and explain you. Right? Here the bases are not same. Here the exponents are same. So what I can do is that I'm going to basically put these two together and have it as the same exponent on the top. That is what they are trying to say. For example, look at it. 3 to the power 2 into 2 to the power 3. Here if you look at it, the base is not same. And exponent, sorry, I'll put it as 2 to the power 2. But if you look at the exponents are same. So if I solve it manually, what do I get? I can put 3 to the power 2 as 3 into 3, right? And 2 to the power 2 as 2 into 2. What do I get? What is the result I'm getting manually if I do it? 3 into 3, 9, into 2 into 2, 4 is equal to 36. I get 36. Right? Now let's use the formula. The same one, if I can do it with the formula, what happens? Your 3 to the power 2 into 2 to the power 2. So they are saying that put these two together, multiply them inside a bracket and put the power as 2. So what do you get? 3 into 2, 6 and 6 square. So 6 square is nothing but 6 into 6, which is 36. I hope that's clear. Understood? Right? This is how. So remembering these formulas in a practical way helps to solve your problem. Don't try to just mug up the formula and start using it in questions, because there will be many questions in your exercises, in your school books, where they're going to confuse you with a lot of things. They are going to basically use 2-3 formulas to ask you to do a particular problem. So you might use maybe 3 or 4 formulas from here. So understand each of the formulas before getting into the questions. Okay, and the last one on the list is that suppose you have something called root 2. What do you mean by root 2? It is nothing but it's written as square root. square root of 2. Right? I can write this one as 2 to the power. If I want to write it in terms of power, I'll put it as 1 by 2. When it is just a plain square root, there is no number given over here. Similarly, if they ask you to find the cube root means 3 over here. So this becomes 8 to the power 1 by 3. Remember, 1 by 3. Similarly, if you have something fourth root of say 16, right, you will write it as 16 to the power 1 by 4. Similarly, you have something called fifth root of 32. It is written as 32 to the power 1 by 5. So basically, if you look at the general formula is that suppose n is an integer, positive integer, and you have some base a. So it is written as a to the power 1 by n. That's the general rule. I hope it's clear. Okay. So now I feel that you might have understood all the formulas what we have covered over here. Now what we are going to do is that we are going to get into problems. We are going to solve some problems which are a little bit intricate. Okay, let's do that. Thank you.